What's going on, everyone? Welcome back. Patrick here, and moving on with another example dealing with infinite limits. We have to find the limit as x approaches pi over 2 from the positive side of this function x squared times secant x. Now notice secant x, that's a reciprocal trig function, and personally whenever I see reciprocal trig functions and limits, I like to change them to be in terms of sine, cos, or tan. So this secant x, I'm actually going to change to 1 over cos x. And the reason why, it just helps me see a little bit better what's happening with this function. So notice that if we try to plug in pi over 2 here, cos of pi over 2 is going to be 0. And then we're going to have 1 divided by 0, which would be undefined. So we can't make a direct substitution. And so we know at that x value of pi over 2, there's going to be a vertical asymptote. So we basically have to see what's happening to the y values as we approach that x value of pi over 2 from the positive side. Now, in the previous video, what we did was we made a table of values where we took that pi over 2 in decimals and then picked a couple of numbers that were really close to it from the right side and from the left side. In this case, you would just pick the right side. And you can do that, and then you could see what's happening with the y values. But in this specific video, I'm actually going to solve this limit with a little bit more work versus just plugging it into a table of values in case your prof wants to see more work. Sometimes they'll be okay with you just plugging it into a table. Sometimes they want to see more work, and that's what I'm going to do in this video. So the first thing I'm going to do is actually take this limit and split it up into two limits. So notice this function, it's like two functions that are multiplied by each other, x squared times 1 over cos x. So we can actually rewrite this limit as x approaches pi over 2 from the positive side of x squared times the limit as x approaches pi over 2 from the positive side of 1 over cos x. Like that. Kind of just took this limit and distributed it to both of these functions. So this is a limit law that you can use, where if you're multiplying two functions, you could split those up and just multiply those two respective limits like that. Now over here for this limit as x approaches pi over 2 from the positive side of x squared, notice we can make a direct substitution here because there's not going to be anything undefined when we plug in that x value pi over 2. So this would end up being pi over 2 squared, which would end up being pi squared, not going to put a bracket, over 4, if we distribute that exponent to the numerator and the denominator. However, over here, we can't do that. We can't make a direct substitution because, again, cos of pi over 2 is going to be 0, and then 1 over 0 is undefined. And so what I'm going to do here, actually, is I'm going to do a change of variable. And what I mean by a change of variable is I'm going to let this cos x in the denominator equal another variable. I'm going to say u here. So u is equal to cos x. And so if we graph this function separately, let's kind of forget about this for now. If we graph this here, if we take cos x and graph it, notice this is pi over 2 over here. So these are the x values, and then these are all the u values. Now you don't have to necessarily use u. You could use y, you could use m, you could use anything you want. In my case, in this specific case, I'm using u. So what's happening as x approaches pi over 2 for this function, for cos x? So as x approaches pi over 2 from the positive side, meaning that we're approaching here, right? We're approaching this x value pi over 2 from the positive side, from the right side. Notice that the u value is approaching what? It's approaching 0 right here. But it's approaching 0 from the negative side. Because notice from the right side of pi over 2, the u values are approaching 0, but they're all negative around there. Now if we were approaching pi over 2, the x value of pi over 2 from the negative side, then u would still be approaching 0, but it would be approaching 0 from the positive side. All the u values would be positive. But in this case, we're approaching pi over 2 from the right side, from the positive side. So all the u values are negative. So u is approaching 0, but from the negative side. And so now what we can do is, here's what I mean by a change of variable. We're going to take all of this, and instead of having everything in terms of x, we're going to have everything in terms of u. So we could say this is the same as the limit where u approaches 0 from the negative side of 1 over u. Okay, this and this are the exact same thing. So we just introduced this new variable u to kind of make it more simple, right? So instead of having 1 over cos x, we're now dealing with 1 over u, which is a function, in my opinion, the reciprocal function, that is a lot easier to deal with. And now this function here, 1 over u, let me write this out again. So x approaches pi over 2 from the positive side is the same as u approaching 0 from the negative side. And now notice this 1 over u, how does that look? That looks like this. Right? Just the parent reciprocal function. And so as we approach, so now the u value is the independent variable. Here it was the dependent variable, here it's the independent variable, because now we have a function in terms of u. So it's the independent variable, and as we approach u from the negative side, as we approach a u value of 0, which is here from the negative side, notice that it's going towards negative infinity. And so this limit here is going towards negative infinity. This limit here is going towards pi squared over 4. And so when you multiply these, notice this is a positive value, and then we have negative infinity. Negative infinity times a positive value is just going to give us negative infinity again. And so that there is the answer. So that's a way where you can do these limits showing a little bit more work. So I know it was kind of complex to go through. Again, you could just do a table of values from here. So you could take pi over 2, again, whatever that decimal value is, like 1.57079. And then you can plug in stuff like 1.5708, for example, which is to the right of that. You could plug it into this entire function, and you'll notice that you'll get negative y values as you get closer and closer to this pi over 2 from the positive side. Right? And so you'll know that it's negative infinity. But if you want to show a little bit more work, then you can use this method where you're doing a change of variable, you're plugging in a u over here. And so as x approaches pi over 2 for this function cos x, from the positive side, u is approaching 0 from the negative side. Right? All those u values are negative before we get to 0. And so when you make that change of variable, now you're just dealing with 1 over u, which looks like this. And as we approach a u value of 0 from that negative side, this whole thing is going to approach negative infinity. And so this limit now is equal to negative infinity. Right? Again, so a little bit more of a complex way to do it. Now, what if this was as x approaches pi over 2 from the negative side? Well, what's going to change then is we would still make the same substitution or change of variable, but now instead of u approaching 0 from the negative side, we're going to be approaching 0 from the positive side. And so this would end up being u approaches 0 from the positive side, and if we look, as we approach a u value of 0 from the positive side, this is going towards positive infinity. So this would end up being positive infinity, which would make this positive infinity. Right? So again, just another way to do these limits, show a little bit more work, and I'm actually going to do one more example like this in the next video.